Okay, so the first thing that hopefully you have some experience with from Math 11 is Radian Measure. So when we talk about Radian Measure, does anybody kind of know what, let me see, how many people have actually know what radians are, or they've actually tried measuring angles in radians? Okay, so some of you I know, if you were in my class, would have done radians. Okay, that's about what normally happens. About half people don't really know what's going on, and that's fine. So basically when we talk about Radian Measure, now as far as I know, does anybody know where 360 degrees comes from? As far as, no? As far as I've been told, I think, so don't quote me on it, but as far as I've been told, the legend was that the Babylonians measured 360 days in a year. That's pretty good for as far back as they were, but it's actually off by 5 days. So if one year made up 360 days, that's 360 degrees made up one circle. So they also counted a lot in base 360, which you have to learn a little of their history, why they did that kind of weird counting. But it's because it's the product of so many different factors, and it made their math a little easier for them. But anyway, so degrees is a convenience. It's not really something that's used. As soon as you leave these doors and you go out into the real world, everyone uses radians. Radians is like the standard that's out there. If you're studying sciences and engineering, that's all you're going to hear of. Degrees is just something that we start off with because it's easier to concept than radians to think of. So here's what it is. First of all, this is the unit circle. So if you haven't seen a unit circle before, this is a unit circle. Now it gets its name because the radius here is 1. Okay. So this is a real important idea because it makes math a little simpler when you work with ones, right? Multiplying and dividing by ones are simple. So for radian measure is going to be the arc length created by an angle in the unit circle. So, for example, the first question says, what is the circumference of the circle here that I'm showing you, this unit circle? What's all the way around a unit circle going to be for distance? Does anybody know that formula? Oh yeah, you clicked in. Danny, what was it? 2 pi, yeah. So the formula was the circumference equals 2 pi r. So the length all the way around on this circle would be 2 pi. So in radian measure, we would say 360 degrees makes an arc length of 2 pi. Okay. So for our purposes, you know, a deep understanding of radians is nice, but knowing how to use radians is more practical. So we're always talking about arc length on a unit circle when you hear radians. And I'll give you some examples of why it's more practical in the real world. So what if we don't want the whole circle? What if instead we only want parts of it? So what about 90 degrees? Can anybody tell me what the radian measure for 90 degrees would be? Connor? Yeah, pi over 2. So one way you can think about it, right, I'll take you back to grade 8. There's my pizza. I got 4 pieces of pizza. So this slice that I have here is 1/4 the whole way around. So 2 pi over 4, which is pi over 2, is how much pizza, or radians if you like, that I've got. So what about the radian measure of 45? 45 degrees, what would the radian measure be there? Sure, Danny? Pi over 4 is correct. How did you figure that out? Half of 90, so you could go pi over 2 divided by 2. Or you could go back to the pizza idea. 2 pi is the whole way around the pizza. There's 8 slices now, so you end up with pi over 4. Okay. What about 180? Pi, yeah, it's half of the pizza. So this time there would be pi. Okay? So you've already been able to do a few radian measures, but let's actually formally put down how this works. Okay? So sometimes It's literally as simple as convert from degrees to radians or radians to degrees. That could be one of your exam questions. So let's find out a convenient way to do this. So if we're going from degrees to radians, what I'm going to multiply by is pi over 180. Now the reason I multiply by pi over 180 is if we look, let's just take, this is a nice one to work with here. We have 180 degrees, which is equal to pi radians. So what I could do is I could say to myself, 180 degrees equals pi radians. So if I want to know how much is 1 degree worth, well, 1 degree would be pi over 180 in radians. Okay? So that's why I'm going to multiply by pi over 180. So I had 30 degrees. Each one of them is worth pi over 180. So 30 times pi over 180 gives me the number of radians. Okay? So similarly, if we wanted to figure out how do we go from radians to degrees this time, can anybody think of what constant we could multiply by? Come on, physics people, you do this all day in physics, right? Is this chemistry or physics converting units? Chemistry? Okay, chemistry people then. You do this all the time, right? But probably not radians and degrees. So what do you think I'm going to multiply by this time? Sure, Connor? 180 over pi. Brave enough to explain it?
It's the opposite of 80.
Yeah, so if we looked at the same little equation I had, 180 degrees equals pi radians. That means that if I want to know how much a radian is worth, 180 over pi is equal to 1 radian. So if I wanted to find out what's 2 radians worth, well, each one is 180 over pi, so it'll be 2 times 180 over pi. And that gets me in there. So you'll notice if you look at these two, that there's pi and 180 are the same numbers in there, both times. Okay? So if you remember that pi and 180 are in there, here's a little trick that I use. If I want to go into radians, like here, radians have pi in them because pi is measuring the length of the circle, right? So if radians have pi in them, I'm going to want to multiply by pi to kind of push it into my answer. Okay. If I'm going into degrees, that means I want to get rid of pi. I want to take out the arc length. So I'm dividing by pi to sort of cancel out those radians. So that's kind of the way I remember which one goes on top and which one goes on the bottom. If I want to go into radians, then pi goes on top so that it kind of multiplies the arc length in. And if I want to come out, then I'm going to divide by pi to take that arc length out. Okay, so it's just one sort of quick way to remember what's on top and what's on the bottom. And there's nothing wrong, of course, with doing one of these little formulas quickly on your margin just to figure out which way it went. Okay, so your turn to practice. Here are 4 of them. 2 in degrees, 2 in radians. Make their conversions and tell me what you get. Okay, so 270 degrees. Does anybody know what that was in radians? Nobody? All right, Danny? Yeah, it's going to be 3 pi over 2. So here's the way I do it in my calculator, just so I can get those nice fractions, like Danny said, 3 pi over 2, is pi, obviously once we put pi in it, we're not going to be able to make a fraction out of it, because otherwise pi would be a rational number. It's not. So 270 degrees, what I usually do in my calculator is I think about it this way. First I'll do that, then I'll multiply it by pi. Because this will tell me, the calculator can tell me that this is 3 over 2, and then I can put the pi on after. So again, if I was to do the next one, negative 320, I would start with this in my calculator, and then divide it by 180. That'll give me the value, and then I still have to attach pi to it. So that would be negative 16 over 9 pi. Okay. So remember, if you put pi in there in your calculator right from the beginning, your calculator won't be able to tell you what fraction that is. So try to do your calculation first and then put pi in your answer. Okay, so this time we're going from radians to degrees, and as I mentioned, you can see that there's a pi in here, and there's a pi in here. So to get out of it, what I'm going to do is divide it. So pi goes on the bottom, and I'd have the 180 on top. So those would cancel out. This would be 45 degrees. Okay. So that's what I mean by pi on the bottom would help remove pi. So there'd be pi 180. Those are gone. So now I'm back in that friendly world of degrees. And that's 450 degrees. So now that we've talked about two modes, be careful when you're working with your calculator. For the TI-83 people anyways, it's the mode button that gets you into radians or degrees. So you need to make sure, because the calculator is not going to warn you, this answer was given in radians or this answer was given in degrees. For example, if I ask for the sine of 30, in one of the modes, I get 0.5. In another mode, I get negative 0.98803 and going. So you can imagine that your answers would be vastly different if you weren't working on the proper mode. So that's the caution is, now that you know about these modes, the good news is in calculus, 100% of the time we work in radians. And in Math 12, we're slowly going to phase degrees out. By the end of next week, we won't use them anymore. But for now, be careful. Degrees can cause you that funny error in your homework. Okay, so here's the one of the big applications of radians, and it's arc length. So let me just show you a bit about this formula. So A is the arc length, and R is the radius of the circle, and theta is the angle. But you have to be careful. It must be in radians for this to work. Okay. So the formula for arc length equals r theta. Basically what this means is, if you think about it, let's say the arc I'm talking about is this far, okay? And let's say this is the unit circle. Okay. If we then were to say double the size of that, then by those proportions, this arc will be twice as long. This one here is twice as long as the one I started with. So if this is the length here, which is the radians, whoops. So if this one is radians, it tells me the length on the unit circle, but I might not be dealing with the unit circle. The radius may be longer or smaller. I have to adjust the proportion. So for example, if I doubled the size of that circle, then I would also double the length of that arc. That's what this does here by multiplying by r. It just corrects how much arc length I'm actually working with. Okay. So for the first example, so you have a radius of 8.2 centimeters. Let's calculate the length of an arc if we made an angle of 3.5 radians or 125 degrees. So in the first example, I'm in radians. I can start working on this right away. This would tell me the arc length is equal to the radius times 3.5 radians. So the length of this arc is 28.7 centimeters. Okay. So roughly, I'll just show you a picture of it. It's going to roughly look like this, where this is 8.2 for the radius. This is the length that we calculated, is how far along is this. So the only thing that can be tricky if you're trying to calculate arc lengths is if you go too fast and you have 125, you might just throw it into the formula and end up with the wrong answer. Can't do it in degrees. Before we do this, we have to say the arc length will be 8.2 times 125 times pi over 180. It has to be in radians in order for this formula to work. So that gives us about 17.89